Hey, what's poppin' YouTube? Code adventurers, welcome back to the Advent of Code 2023. Chris here, and can you believe it? We soared through the pipe maze of day 10, actually we struggled quite a bit, and embraced the explosive expansion of day 11 in one thrilling coding session, although I put it in 3 videos for you guys. If you missed the astronomical excitement, catch up because tonight we're launching into day 12, and I've got my coding spacesuit on for another interstellar adventure. I hope your coding constellations are aligned and your cosmic coffee is on standby because tonight's challenge promises to be one out of this world. If you haven't joined the Code Adventurer crew yet, hit the subscribe button, give it a like if you're ready for tonight's cosmic coding odyssey, and ring that bell to stay in the loop with all things Advent of Code. After navigating the cosmic expanses of day 11, I'm pumped to see what extraterrestrial challenges are of day 12. So strap in, clear your coding launchpad, and let's code our way through the stars for day 12 of Advent of Code 2023. Code adventurers, are you ready to reach the new coding heights and explore the cosmic code tonight? Let's launch into another coding victory that is well over 12 hours behind. I told ChatGPT that day 11 was about cosmic galaxies, and it just assumed day 10 was as well, and that we would be going somewhere in space into day 12. So, let's see. Day 12, hot springs. That has nothing to do with a galaxy. Day 12, hot springs. You finally reach the hot springs. You can see steam rising from a secluded area attached to the primary ornate building. I could just see myself showing up to a hot spring in a spacesuit. Anyway, as you turn to enter, the researchers stop you. Wait, I thought you were looking for the hot springs, weren't you? You indicate that this definitely looks like hot springs to you. Oh, sorry, common mistake. This is actually the onsen. The hot springs are next door. You look in the direction the researcher is pointing and suddenly notice the massive metal helix towering overhead. This way. It only takes you a few more steps to reach the main gate of the massive fenced-off area containing the springs. You go through the gate and into a small administrative building. Hello, what brings you to the hot springs today? Sorry, they're not very hot right now. We're having a lava shortage at the moment. Aye, shortage after shortage after shortage. You ask about the missing machine parts for Desert Island. Oh, all of Gear Island is currently offline. Nothing is being manufactured at the moment. Not until we get more lava to heat our forges and our springs. The springs aren't very springy unless they're hot. Say, could you go up and see why the lava stopped flowing? The springs are too cold for normal operation. But we should be able to find one springy enough to launch you up there. There's just one problem. Many of the springs have fallen into disrepair, so they're not actually sure which springs would even be safe to use. Worse yet, there are condition records of which springs are damaged. Your puzzle input are also damaged. You'll need to help them repair the damaged records. In the giant field just outside, the springs are arranged into rows. For each row, the condition record shows every spring and whether it is operational or damaged. This is the part of the condition record that is itself damaged. For some springs, it is simply unknown whether the spring is operational or damaged. However, the engineer that produced the condition records also duplicated some of this information in a different format. After the list of springs for a given row, the size of each contiguous group of damaged springs is listed in the order those groups appear in the row. This list also accounts for every damaged spring, and each number is the entire size of its continuous group. That is, groups are always separated by at least one operational spring. It will always be 4, never 2. So condition records with no unknown spring condition might look like this. However, the condition records are partially damaged. Some of the spring conditions are actually unknown. For example, equipped with this information, it is your job to figure out how many different arrangements of operational and broken springs fit the given criteria. In each row, in the first line, there's exactly one separate group of 1, 1, and 3 broken springs in that order can appear in that row. The first 3 unknown springs must be broken, then operational, then broken, making the whole row. The second line is more interesting. It can be a total of 4 different arrangements. The last question mark must always be broken to satisfy the final contiguous group of 3 broken springs. And each question mark must hide exactly one of the 2 broken springs. Neither question mark could be both broken spring, or they would form a single contiguous group of 2. If that were true, the number afterward would have been 2, 3 instead, since each question mark can either be. There are 4 possible arrangements of spring. The last line is actually consistent with 10 different arrangements. Because the first number is 3, the first and second must be. If either were the pound, the first number would have to be 4 or higher. However, the remaining run of unknown spring conditions have many different ways they could hold groups of 2 in one broken spring. In this example, the number of possible arrangements for each row is 1, 4, 1, 1, 4, and 10. Adding all the possible arrangements counts together produces a total of 21 arrangements. For each row, count all of the different arrangements of optional and broken springs that meet the given criteria. So what I have, I'm using Freeform, which is an app native on Mac. And Freeform has this ability to share a session between an iPad and, let's say, a MacBook. And so we can use that I can draw on the iPad, and then we can see the different results. So if we take an example, let's go back and let's look at, we're going to kind of walk through this, and we're going to look at this first example here where we have the question marks, etc. So if we had a question mark, question mark, question mark, I'll bring up the screen here in a second, a dot, and then 3 hashes. And then we have the broken configuration, which is 1, 1, and 3. Okay. So let's look at this together. So this is what it looks like. My handwriting's not perfect. Actually, let's define this as our input. And then our output needs to determine which of these 3 question marks are the springs that meet this criteria configuration. And one of the rules is they must be separated by a period. Okay. So our output, our expected output in this case is going to be spring, period, spring. So, and then you've got your spring, and then the 3 springs that are already known. So there's only one possible configuration for this given set of input. Well, the question becomes, well, how do we determine that? How do we get to a point where we can analyze that? So the method for this is we can take an approach with some bounding options to keep us kind of on track. So if we know we need 1, 1, 3, we need to assess these one at a time to see if they're resolved. And we have to think about it as the configuration must be 1 spring, 1 spring, 1 broken spring, 1 broken spring, 3 broken springs. And so we're going to start with trying to resolve the first one. So if we highlight this one here, we're going to start with trying to resolve that. So we're going to start at our first character position, and we're going to say, can we satisfy the 1? And the answer is yes. But we have to check also the next character position, which is here, because if it is a spring, then that's not a contiguous of 1. So we know the first one is a question mark, and that becomes our hash. And then this one becomes our period. And then we now have resolved this one. So now we move on to checking the second one. And we'll check this one. And since this is a question mark, it can become a spring. But we also have to check the next character to make sure that it is a period, which it is. So it is valid for this to become a spring. We'll move forward to our next character. And since we've already solved this, we are now trying to resolve this. And we can see that there is a spring. Good. We go to the next character. Spring. Good. Next character. Spring. Good. Okay, and that's essentially how we're going to resolve this algorithm. Now, this is a simple case. So let's look at a more complex case. Let's use, I don't want to do too many iterations, but let's use this one as our example, this more complex array. So here's our second example. Now, there are 4 possibilities in this configuration. And remember, we are looking for 4 possibilities. We want to first start by resolving the first num on our stack, which is 1. And so we're going to start at position 0. And we're going to see that that's a period, so that doesn't resolve anything for us. So we move on to the next one. And we see that we can resolve a 1. So this is our first resolution. And then we have to check the next character, and we can turn this into a 0. Actually, let me do this. We're going to keep with yellow here, and then I'll do the next one in blue, and then we'll do one in green. So this becomes a dot. So this becomes a hash. That becomes a dot, and we've resolved the first one. We're going to move forward, and we're going to do this. We're going to find this one, and we're going to see that this one is not set. So we'll set it to a hash, or count it as a hash. And then we have to check the next one immediately to make sure that it is either a 0, or a period, or we can make it a period if it's a question mark, which is what we're going to do for this iteration. So that one is resolved, sorry. And then we're going to check this last one, which is a 3. And we're going to find this one, and we're going to see that it can be a hash. So we're going to make it a hash. And we're going to move forward and see that it is a hash. It is a hash. And so that's our first configuration. So good to go there. So let's look at our next one, our next possibility. Well, when we complete this slice, we have the way we're going to do this efficiently is we're going to go back to the start of that slice, so which is here. We'll use red. I'll erase this previous mark here, make that yellow, and then we're going to use red. So we're going to go back to the previous start here, and we're going to say we're not going to use that one, and we're going to move one character forward. And if that one can be resolved, which it can, as a broken spring, to resolve step 1 here, we have to check the next character to see if it is a period, which it is, so that's allowed. That one's done. Then we move on to the next character, and again, this one can be a spring. So we're going to go ahead and set that one as a spring. And then we're going to do this one as a period, again, because it can be, and then this one as a spring, which will resolve these two. Okay, that one's kind of fine. And then we've got one more, if we want to do, I won't do all of them, but we're then going to start our next iteration wherever we started, and we're going to scan through, find this one, hash, period. I did forget there is one other thing we have to do. I skipped a step. All this is true, but there's one step that I'm skipping here that I want to highlight. So let's look back here on this first step here when I moved forward a hash. There's one other intermediate step that I have to do where when we're back here, if it's hashable, which it is, if it's a spring, if it could be a broken spring, so I need to check the next value, which is here. And only if it's a period do I want to move forward and skip the next start of spring, because we want to make sure there's not another check in here. So in this case, it doesn't make sense because it's a question mark. But if it happened to have been a period, we'd want to start an iteration forward. But we're going to get there anyway. So let's go back to this example. So because red finished, we're going to start here again, right? And we're going to check, since we're starting here again. Actually, yeah, I should have done it in the previous example as well. We're going to start here again, and we're going to check each character. That's valid. That's valid. And wherever our second spring starts, right, which would be here, we're going to skip that. And we're going to say, can we create... So we're going to skip, and we're going to say, can we create a spring at the next one? And because we can, or create a broken screen, because we can, we're going to keep moving forward and finish out our broken spring. In order for us to do this, we actually have to go through more iterations. The next iteration will look something like skip, skip, can I do a hash, can I, no, and we end on 3. So this would not be valid, right? But that's what the iteration is going to look like. And so we have to recursively scan from our start position, and we skip one moving forward so that we can get basically running 2 indexes. So you have an index of I and J kind of moving through this the entire way and trying to get the different iterations based on the start and stops of the spring. So computationally, it's not great, but it will work and it will guarantee our results. So I like to take an implementation, a stab at that. So let's see what we can do here. Let's think about our scoring function. And let's think about our parsing. So let's look at our input. Let's parse this part real quick. So what we're going to do is just not do this, and we're going to do for line in range of strings dot split s we're going to create 2 kind of things. We're going to do springs, which is just going to be a slice string, and then we're going to do, what do they call it in here? Let's see. Oh, we'll just call it records. Okay, and so I want this to be a slice of int, and actually a slice of int. So we're going to break it apart, and then so we have to split the line apart by the space. So what I'm doing in this first split, if we look at our test file, is I'm breaking the line apart, and then I'm splitting this into 2 sections. The left section is our springs. So we're going to do springs equal to append springs items sub 0. And then as far as our other input goes, those are ints, and I don't want to represent them as strings. And so I've been kind of building some helper functions. What I'm going to do is I'm going to have a function called as ints. And this as ints is going to take in a slice of string and return us back a slice of int. Yeah, for s in range of items, and we'll call it ints. Yeah, and then we'll say string convert a to I s. We're just going to panic with the error if this happens. Otherwise, ints equal to append ints I. Okay. So this just allows me to quickly convert these in the future. As I come across these, I'll have the helpers. And then so we're going to do records equal to append records. And then we're going to do as ints, comma to as ints, and we're going to pass in items sub 1, and then but it's actually strings dot split, and we're splitting on the comma, and our input is items sub 1. Right. Okay, so that should give us our springs and our records. Printf. I don't want to keep doing that. Let's just make sure we got that. Those are our springs. Yes. 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 Okay, perfect. And then our ints. All right, so we got that. So now we want to create a score function, or what's the word here? Arrangements. And we're going to take in our spring, which is just going to be a string. And we're going to take in our record, which is just going to be a slice of int. And so now what we'll do for this is we're actually going to create a test arrangement func. And then record. That's our input, and then our record is the ints, and we can say 113, and then our input is that. So let's solve for this case first before we get too crazy. Missing return, return 0. Okay. Well, we just kind of chop this up in individual pieces a little bit more. Right. So I mean, technically, I don't have to track the position of the second hash or second spring, but I feel like that might help us just kind of keep track of the different position. And then, yeah, so this is really I. Yeah, so let's think about how to approach this. So we want to, I know we want to range over the string. But we're going to do that many times. And the start index, I think, is going to vary depending on where we are. So we're going to loop through that. And we're going to start on our first character. And so what I want to do is track our continuous run and then track our rules as we go along. So what we'll do is we'll say if s sub I question mark. Was there a rule that there always has to be a period on the right side? First and second must be both. Nope, this is a valid example. So if s equal to a question mark or s sub I equal to a we're going to say that our current is a question mark, and the next value, we're either at the end, or our next value is a dot, or our next value is a spring. That is okay. However, we might end up with an edge case here where if this is true, then we need to understand what the continuous value is. But I don't think I'm going to worry about that so much. Let me ignore this for 1 second. If this is true, meaning that we have a question mark and we reach that, then we can scan forward and know on the next iteration if we've satisfied. So I think what I want to do is, if it's a question mark, then we consider it satisfied. And then if the next value is either a hash or a period, we check to see if our count, yeah. So if no. Okay, I'm almost here. If our counter J yeah, okay. If J something I want to do. Okay, so we know this is valid. So if S is period, right, so J is going to be my current counter. That's going to be how many values we have. And if J equals our record count, we're going to do R plus 1, and then we're going to do J equals 0. If R equal to 1, so if R is equal to length of record minus 1, then we've got our total count, right? So var total count, int, and we're going to return our total count. Okay, so I think that's starting to make sense, so that each time we get through I, then we increment our value. This does imply, however, that we would miss the last spring. So we'd have to have a condition for that if we so choose. Alternatively, we can check forward. And if we're on a question mark, and this is true, we increment our running total. But the minute we hit a period, we have to reset it to 0. That would allow us on the last hash to increment our counter. Okay, so what if we did that instead? If s sub I equal to hash, then j plus plus. Okay, so we're going to increase our current counter. If our current value has reached a period, then j equals 0. Yeah, so we're going to reset it to 0. And then when all of that is done, if j is equivalent to our record, then we're going to move our record index pointer forward, and if j equals 0, then our total count is plus or equal 1. This should solve for our base case. So this is not what we want. We want resolved plus equal 1. And what I have total count. Yeah, we don't want to add to the total count here, right? We want resolved to be incremented, and then oh wait, we don't need this in here anymore. Yeah, don't need that. And then finally, if resolved equal to the length of records, so we're counting the number of things that we've resolved, and if they're the same, that's when we're gonna increment total count, or we can just do by 1. Okay, good. So that's our base case solved. So if we go back to our diagram that we did earlier, that's kind of this base case here in this area, where if we don't have to do any additional checks, we're good. But then we have this more complex version where we not only have to move our left index forward, but we need to check these other potential like configurations in between. Yeah, so let's add a more complex fig and let's solve for that. So let's go with this one here. It's a little bit more complex and we want 4 out of it. So let's create a test and 4 input. We'll go with all of this and then we'll cut this out. We'll say record int is this. And of course, if we run that, it's not going to be solved. So, interestingly enough, 0. Well, I expected at least 1. So let's figure out why we didn't get 1. We have a question mark, and we have 3 things to resolve. Let's see here. So, our index would move forward. It'd find the first one. It'd see that the next one is a question mark. So we don't have that particular configuration. So if we're going to do that, we'll just split this into a separate rule. So if it is a question mark, we can represent it as a period. So is it just j++? Well, let's look at our first example. So I am automatically incrementing because of that. So if it's a question mark, we can increment the j. If it's a question mark and our next character is a question mark. So I think this one was actually, it's broken in its current state, even though I got the right result. And so because we failed this violation of, When we got to the second question mark, so we marked it resolved, and we didn't validate if that was true. So what happened in this first example is actually we ended up with spring, 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 or something like that. But that can't happen. So when we mark something as resolved, we need to check. So if it's equal to a broken spring, this is where our R is, which is our full record resolution. But what we really need is this, because if J equals our record, so 1 and 1, then we want to mark it as a record resolved. But the issue is that if the next character is a spring, that's not true. So we want to actually negate that, and we want to continue, so that the count removes from one from the end and it goes to the next one and continues to read forward. If the next one is a question mark, then we're going to do I plus plus, because we actually want to move past the next index, and then we can allow this. If I is a period, so I think this works in that this only matters if we get to the full length of the record. So for things that are continuous, it should be on that record. So the only thing I need to check is if the length of S minus 1. If I yeah, so we don't want to get out of bounds, right? So if I run this, am I still passing my first? No, I'm not. I'm failing it again. Okay. So let's look at this for a second. So I is 0. We start at we find a 0 index. We find a question mark. And I is not at the end. And the next character is a period. Okay, well, that's not true. It could be a question mark as well. Okay. So if any of that's true, so we're going through here, we get to the first character. We're not at the end, but the next character is a question mark or a period. So we go here. Cool. Which means we don't do anything here. We don't do anything here. And so we get into here, and we see that our J count, which is our count, our current count, is equal to the record R of 1, the first one in the list. And so we come into here, and we say, is I less than length of S2? Yes. Actually, this should be a 1. And if I is length than less of S minus 1, then is I plus 1 a question mark, which means it needs to be a period. And we I plus plus that. We increase our resolutions, and then we come back. So this was an attempt to jump over that second value. So if I comment this out just for a second, and I look at resolved, so we should get 2 resolves, right? And so my I is now at 4. So 0, 1, 2, 3, 4. Okay. Ah, this is actually length of record. All right, so what am I missing here? It's probably obvious, but we're gonna step through this again. So if we hit a period, j equals 0. Okay, let's walk through the breakpoints again. So debug, right? So we've got our record. We've got r, which is 3 equal length of record. So resolved is plus equal to 1. I think this is just confusion. Yeah. All right. Get rid of that. Okay. So this is the count of what index we're on. So 0, 1, 2. And when we get to 3, that means we've resolved everything that needs to be resolved, right? It's going to be off by 1, and then we can consider that total count successful. And I think what we can do is actually move this into here, and then we do a break there. So that still solves our base case, but then we get into this case, okay? And we should get a 1. I'm still getting a 0, so let's figure that out. So our base case is still solved, but we're getting a 0 here, and I'm expecting at least a 1. So what I'm looking for is the first index to be counted as a question mark, and then the next index to be counted as a period, and then we move forward, and then that happens for number 2, and then finally for number 3, and that doesn't appear to be the case. So what are we looking for here? So the first index is a period, j is 0, and really we can just continue here just for logical make sense. In fact, we'll move this one up to the top. Okay, so we're going to come back through and we've got a question mark. So if we've got a question mark, we're going to increase j as long as the next value is a period or a question mark. So that's interesting. So I think this needs one more, which is we only want to skip forward because it has to be a period. So we have to have a space there. So we only want to skip forward if yeah, that's fine. Only when our record is matched do we skip forward. So we're already okay. So I don't think that's the issue. So let's see how many times we hit this condition with the second test. So j1 equals record sub 0 sub 1. Okay, so we don't hit it after the second one. So let's debug that again. And we'll go straight to the second one. And where is I? I is currently 5. So I is 0 based, so 0, 1, or 0, 1, 2, 3, 4, 5. So we're here, okay? And we decide that it's going to match. And so we don't go backwards. We do increment forward. So I should be 6 now, 7. 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6. That's where we want to be. We want to be on this period. Okay. Good. Continue. 8. Good. 9. Good. 10. Awesome. So S of I is equal to a question mark and should get a J++. Okay, that didn't work. So why? Because the next character is a hash. So a next character of a hash is okay. That's okay in this condition. Okay. So if I run that again, it gives me 1. Do I still have this in solidarity? I should. Okay. Good. So the only downside to that is that what if this is true, what happens if, so for our next value, okay, good. So now we've got ourselves our base loop, I think. So now we need to figure out, how do I get through this thing multiple times and I change it in such a way that I inevitably end up with different results? Is there always 3? No. Okay. So let's think about this a little bit more. Okay. Let's go back to our diagram. So we know that what we're going to have to do in this case is we can figure out a different configuration by moving our index forward 1 from our last start position and indexing that forward. Let's look at some of our examples. So this is a pretty extreme case where from the same start, they moved the last index. And then they move the second index by 1, and they move the last index. And then they move the second index again, and so on. Let's look at our original sketchboard, and I did some other sketching, but we're going to focus in right here. So in order to make this, to try the different types, what we're going to do, we stay focused in on this example. And we know we have 3 things to resolve. And so the way we're going to do this dynamically so that we can get all of our resolutions is our function is going to receive in a starting position in addition to the 2 things it receives in already. So what we have already is an arrangements function that is just a string, but it doesn't have a starting position. So we're going to give it a starting position, which will be the position of I. And what we're going to do, so it'll be the string, the start, which will be initially 0, and the records, which are the rules that we're looking for, right? So that's what our function, that's what we're going to change our function to receive. And the reason we're going to do that is because we're going to start here at position 0 initially, and then we're going to move forward. And as we find something that meets a rule. So for instance, in this case here, we know that rule 1 is satisfied. So then we're going to recursively call our function up here. And so you can imagine the initial input is going to be something, this whole string, plus 0, plus 1, 1, 3 for the first pass. The second pass through, because we have resolved here, the second pass through, it's going to be, our string is going to be from this point. Here, let me change the color. It's going to be from this point forward. Actually, we don't need a start because we're going to pass in the modified string. Although I guess we could use the same string and just pass an index. But we're going to be looking at it from this point forward. And we're only going to pass in the last 2 records. We're going to ask it how many times it finds that. And then in turn, that function will recursively call. And when it gets to this position and it resolves here, it's going to pass in here moving forward, and it's only going to pass in the final rule. So that's the plan, to create this in a recursive way, and we can get a count of the final resolved functions, essentially. So that's the idea, and that's how we're going to change our function. So let's look at it from that perspective. So that means that we don't really have to do an outer for inclusion here. We can just call arrangements, and we don't have to worry about resolving all of the records. So we've got some progress here. I don't really want to lose that. So I'm just going to create an arrangements 2. And what we want is, when we get to this point here, we don't need that. We want this point here. And so if we get to record 0 and we pass these 2 checks, then we want to see what we're going to plus the arrangement possibilities of S sub I to the end and our record sub 1 to the end. So the reason we're doing 1 is because we only really care about the first record here. And then we're not going to worry about R. This is just going to be total count now. And really, R doesn't serve a purpose anymore, because we're not counting the index. And so the way this will work is that we need to think about this slightly differently, in that we want to reset I. Okay? Because in the first iteration, this loop, it's only going to be looking to resolve the first record that it has. And so we need to see how many times that is true, and we pass it into arrangement. So we're going to do one more exit strategy up here, and we're going to say if record equal the length of record equal 0, that means we resolved all, and we're going to return 1. And so what we want here is, instead of I continually scanning forward, we want to go back to wherever this record match is and start sort of over. So I should equal to So I should equal to I minus j, or so we could do minus equal j. The reason we're doing that is because we want to put the index of I back at the start of wherever we found this first record match. And then we want to let it +1 here, which will give us the next character. So to kind of explain here, when we process the yellow, let's see if we can do a box. Yeah. So when we process the yellow here, our next arrangement is going to be everything after it. But we need to know if moving our index forward 1 here can match so that it can pass the next set in. And so that's what we're looking for here, is just setting I to that back to, because the arrangement size could be 1, it could be 3, it could be 10. And so we're going to go with that, and then we're going to pass in. And so the only time this is going to be true is if all of the records are satisfied. So I think this covers it. Let's try. Let's try this. Okay. So it immediately is in some sort of recursive loop. So my guess is that we are either assigning I back to itself and it's recursively sending in, or I is not the right value here for what we're sending. So let's debug. Let's debug. Okay. So S of I, which is 1. So that should be, if we can watch this over here, that is 1 character forward. So that is our second question mark. Okay, that's what we want. Well, do we? No, we actually want it 1 character in front of that. Yeah, we always want to go 1 character ahead. Even though we've done this, which will represent that space, we do want to be 1 character ahead. And then record is always going to be from the 1 position forward, so it's going to be the next rule. And then we want I for the next iteration. We want I to be 1. So this is going to put it back at 0, which is not what we want. Because we want to move to that next index. So I think we need to subtract 1 from j, which will be 0 on the first iteration. And I think that's actually what we're looking for. Okay. Okay. So we have at the very least are matching on the first one, but it doesn't seem like we're getting more iterations than that. So let's try to figure out why here. Actually, I think this needs to be 0 because I is going to iterate +1 up here. So maybe that's the... we should recursively call arrangements too. That would help. Okay, so back to here. Okay, if we focus in on this example, not this one, we know that when the string is this, here, let's put a conditional breakpoint. We'll conditionally break it back because I'm curious how many times we enter here. So the first time we enter, I is what? I is 2. So I is 2. If we look at our string of S, that puts us at the second question mark already. So if we do 2 minus equal, that puts us at index 1 is what we're going to start back at. Index 2 actually, which is not what I want, because this is going to be 2 minus j minus 1, which is 0, which will put us at index 2, and I actually want index 1. So how do we fix that? I don't actually think I need this anymore because we are just moving forward one index at a time. And so this is not needed in this arrangement. It's not needed for the current index, but this should start not at 1, but because the next one is a question mark, it should start at 2. So and we'll do so we're fast, and we've got I, S of I forward. It's going to be the question mark. But we want plus the mod, which will be 1 because the next is a question mark, and we know we need to skip at least that one. If it's a period, we're fine. And if it is a pound, then we know we need to keep processing. And so if we come here, our total count is 2. That's good, right? I think that's true because we have just 2 arrangements with that first character. And then I is going to be I minus 1, j minus 1. I think we want I to be 1 less than the previous length. So in the case, this doesn't make sense for something that is a 1, but something that is a 3, it makes more sense. So this is going to start at the 0 index for this iteration, which makes a ton of sense. All right, so back here, now we're at position 2, which is that second question mark moving forward. And we should also get 2 possibilities, which puts us at 4. Okay, cool. So that's solved. So then let's try one more complex example. All right, interesting. Okay, so now we've got we've got 20 and the expected is 10. So why did we get 20? Why do we think we only need 10? All right, so let's do some similar debugging. We're going to add our conditional breakpoint here. We're going to say s is equal to the primary string so that we can kind of process this forward and kind of see where we're at. So yeah, let's do it. We're going to comment these out and we'll stay super focused on this one example. All right, so the first one, we find ourselves at index 3. So that is 0, 1, 2, 3. Okay, great. And the next one is a question mark. So we need to go 1 forward. And we're asking it how many iterations it can find with just a 2 and a 1. Okay, great. So that's awesome. And this does mean that our next iteration should, aha. So this is why. So because we have these broken springs already mapped, I can't just move one index forward because those are actual springs. And my start of block is already a broken spring. So what I'm doing right now is I'm passing in from the second broken spring, the second pound there on the screen. That's what I'm passing in. And it's going, aha, I can resolve you because. And the reason it's thinking it can resolve is because it has no awareness of the previous spring. So how do we solve that? So one thought that I have right now is we could check the value that we're going to. It's okay if it's a spring, but it's not okay if the previous value is a spring. So if our destination is a spring or a question mark, so this one is saying, hey, we need to add an extra space, right? So I plus mod plus 1, I is 3. The issue is not what's being passed down. I actually think that is okay because this is handling that and it's saying, hey, add a 1 onto the end. So this effectively is actually, we should update this expression here and see that it's the length of question mark. And let's just call this S so we can see it side by side. So 1, whatever that is, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So we're starting here, which is accurate forward thinking. But what the problem is when we shift back up, we want to shift forward until we get through the sequences of the springs. Once we solve this last piece, we're done. This part of the problem is solved. So yeah, so we know if we have a match and it's a contiguous spring. So let's think about this. If we have spring, question mark, spring, question mark. If it's a 3, well, it's going to have to be all 4 of those. And if we come back, we don't want to start here. We don't want to start here. We want to start here. Now, what if it's that and it's a 3? Well, that's not valid. That's not valid. But that's valid. What if it's this? That's valid. That's not valid. That's valid. And that's valid. So what I think we need to do is, if we have a match, we need to, if sub I equals our pound, and s of I minus 1 also equals a pound. So let's think through our example here. So what we're going to do is move it forward 1 index. So we're going back to, we start here and we get these first 3, and that's good. We move forward and we're starting here now. It's a question mark. So it could be a pound. We need to check the previous. Okay. Is a question mark. Okay. So if it's question mark, we check the previous. And if the previous is, oh, sorry, I put that on the wrong side. Yeah, sorry. So if our destination is a pound, then we're going to say, okay, so we start here, we're good. We move our index I here. We see that's a question mark, and the previous one is a pound. So we know that that has to be an empty space. So we move forward 1. Okay, we're here. We look previous. It's not a pound, it's a question mark, which means this configuration is technically valid. It could be a period. And so we process, we process from here forward. And that's valid. We then move forward to this one and again process, and that also could be seen as a 3. And if we have that configuration, the answer is no. So I think that solves that problem. All right. So we got an index out of range. I knew we were getting close to that. All right, let's look and see what's going on here. S is that, got it. I is what? I is 0. Okay, so I is not, technically, I is 1 iteration behind where we're going. So I is set to, so technically this needs to be +1 at this point. This needs to be I +1, and this needs to be that. Okay, and so we end up with the opposite problem, which is when we get to the end of the string, we're assuming there's going to be another character. So I is less than length of s minus 1. Okay, 13, it's better. I'm intrigued on how we got to 13. Yeah, the difficult thing here is because I'm not carrying the string forward and I'm not manipulating the values, it's a little more difficult to see exactly what's going on the inner workings here. But let's go back to what we were doing previously. So let's just see how my other simpler cases fare out and see if that brings anything to the surface. Okay, no, those are still good. Okay. I think there's one other condition in here where we're not skipping forward. So let's see here. Okay, so I got 10 right out of the gate. Is that right? Okay, luckily we've got this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's definitely 10. Okay. Cool. So I agree with that. And we're at index 3. So we're going to go back to 3. 3 minus 1 is 2. So we're going back to index 1. So what we're asking now, okay, so we said, is the next character a pound? So s of I plus 1, which if we add this to our expressions over here, we can see that, okay, well, it's our hash. So the problem is we've added 1, but even though we've iterated forward 1, we still have this issue of s of I is still a hash as well. We can see that here. So because of that, what we actually need to do is we need to loop forward and make sure that s of I is not, so where we're headed. It can be a hash, but only if the previous is not a hash. So we need to iterate forward out of it. And so what I'm going to do is this and just say for. So we'll just go ahead and iterate through until we get to the very end, and then we'll break essentially. So I think that solves that case. And all right, cool. So now we've got, let's just put in a couple more examples here. Yeah, so this is a 1. And then we've got this one, which is a 1. And we'll do one more, which is this one, which is 4. All right, cool. All of our test cases pass. So then, whoops. All right. And then, so let's go and let's solve. So arrangements is gone. Let me just fix this real quick. That's gone. This is arrangements, and then we'll call arrangements recursively. And then we update our test to call arrangements instead of arrangements 2. And these all still pass, good. And then finally, we want to look at our scoring function. So what do we want to do? Adding all the possible arrangement counts together produces total 21. So that's total arrangements for everything. So then as far as our score goes, so we can then do arrangements, springs, and records. There we go. We could do it inside here, but it's fine. I'll parse it separately. And then that should be that. And then what we'll do is we'll grab our puzzle input. So this is my input. And we're going to put that into our 1.txt. And we're going to run day 12. Declared and not used. All right. 9386. All right. What do we think the issue is, boys? Which edge cases do you think are not recorded here? Yes, I think 6 is correct. Okay, let me test this out and see. It's been a lot of debugging today. All right, there we go. But as always, over and out.